Alright, so this problem is a system of inequalities and the applications. Ready? You have at most 8 hours to spend at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? Alright, so first, let's define variables. What are my variables?
Time.
At the
Mall.
and time at the
Beach.
Okay, so I'm going to say X is time at mall, and Y is time, and this is in hours, at the beach. You have at most 8 hours to spend at the mall and at the beach. Equation? X plus time at the mall
Y.
plus time at the beach. X is my time at the mall plus the time at the beach is at most 8 hours. At most is less than or equal to 8. You want to spend at least 2 hours at the mall. So mall is X. So X is great. You want to spend at least, so X is greater than or equal to 2. And more than 4 hours at the beach. So Y is greater than 4. Alright, so we have 3 equations. So we got 3 equations out of this. 3 equations, 3 constraints. We could look at all knowing the same thing, right? So equations are constraints in this case. So I'm going to take these 3 equations. And I'm going to go to my graph, and I'm going to graph these 3 equations. So first I'm going to label my graph. So this is the hours at the mall. This is the hours at the beach. First equation. X plus Y is less than or equal to 8. What's the easiest way to graph this? Intercepts. If X is 0, Y is 8. 1, 2, 3, 4, 5, 6, 7, 8. If Y is 0, X is 1, 2, 3, 4, 5, 6, 7, 8. First equation. Less than or equal to, solid line, dotted line.
Solid.
There's my solid line. And then I got to figure out where to graph this. So we could use a 0, 0 test. We could test the origin. So I'm going to use this coordinate as my test. So if I plug in 0 and 0 for X and Y, I get 0 plus 0 is less than or equal to 8. Is that a true statement?
Yes.
So that means I'm going to shade towards the origin. So I'm shading all this. And actually, this would actually shade below as well. My second equation is X is greater than 2. So this is a vertical line at 2. X is greater than 2. It's a vertical line at 2. And since I'm greater than 2, so I'm going to shade this to the right. So I'm going to shade everything this way. But notice when I shade this, I'm not going to pass the first line that I drew, right? That first line that I drew is it's called another boundary line, right? That's the boundary. You can't go past that. Then my last equation is Y is greater than 4. So let's make sure it's a, what kind of line? 1, 2, 3, 4. Make sure this is a dotted line. Okay. So if that's my dotted line, then I'm going to shade this. It says greater than 4, so I'm going to shade above. So I'm going to shade above here. And the region that I shade is only in this region here. Because I go above, and this is my boundary, so I can't go to the left of this line, I can't go to the right of that line. So this is my only solution there. So a possible solution here, so if let's say I pick this coordinate here. So this would be an x value of 2, this would be an x value of 2, and a y value of 1, 2, 3, 4, 5, and a y value of 5. If I plug this back into my first equation, 2 plus 5 is less than 8, is that true? Check. X is greater than or equal to 2, is that true?
Yeah.
Because 2 is equal to 2. And 5 is greater than 4, is that true?
Yeah.
check. So that's one of my solutions, all right? So anything in this region would work, but be careful here, right? So if I pick this coordinate here, that wouldn't work because what? What the line that it's on is what?
Dotted.
It's a dot line, right? So that means it's not inclusive, so I don't include that point.